Hello world, I am live. I am live. Can you hear me? Check, check, check 1, 2. Hey KNN, Kirk News Network. It's either watch this or go outside and cut up a fallen tree. Okay? Cutting up a tree while looking at your phone is still legal as far as I know. G'day Tommy. G'day Let Me Look. Hey Toby. Yep, it's good, is it? How's the audio? Because I did tweak my microphone before this. Is my microphone good enough? How's their audio? Good, good, says Jupe. Evening from the old dart. Good audio, good morning, mic is good. Good day, ITSD, Thomas. Megahertz UHF. What? Whacked man in the house, of course. Mic is good, thank you. Good volume and clear. Excellent. Crisp audio, no room noise. Well, I do have the aircon on, so it's not on. It hasn't switched on its cycle at the moment, but every 5 minutes or something, the aircon switches on. I think I've got it on. Otherwise, it's going to get a bit warm. No, it wasn't on. It's on now. I don't think you'd be able to hear it though. You'd have to really gain it up. But so I just got in, by the way. So has anyone been following this? Can you give me an update? Because I have. Sounds good. What's PDI ignition? Landing. There's a 45-minute counter. Hello, Leah. They're at Intuitive Machines. Oh, no, she works for NASA. And who had heard of Intuitive Machines before this? Anyone? Anyone? Hey, Retro. Hey, Dirk. Hey, Roberto. Audio is a little soft. Sounds like halfway, does it? Everyone else said it was good. I can turn my mic up. It's just that I was listening to my video that I haven't released yet, but I released to patrons last night. I was listening to that, and it seems a little bit overloady. There's lots of plosives, in my, even though it's got a massive filter, you know, it's got a huge. Not only does it have a filter in there, but it's also got a pop filter on the outside. So, I don't know. Don't know what the deal is. And it's a pod mic. It's a Rode pod mic. And I was playing around with it, but anyway, there you go. I'm a bit louder now. Check, check. All right. Good. Let me guess, another American corporation. They'll say they're on the moon when we get there. Yeah. I can. Right, what I've got here is, I can overlay comments like that. So what's happening is I'm streaming through StreamYard. So I'm streaming to multiple. I'm streaming to X, YouTube, and Facebook. But the comments you see here, they are only from YouTube. So so if you want to comment on, Facebook, I can look over here. I can look over on my StreamYards tab and I can see my Facebook comments. I can't see X comments. StreamYard cannot pull in X comments. So, look at his beard. I'm telling, look, I'm calling it now. This thing is going to make it. Just based on that controller's beard. I'm telling you, confidence is high. I repeat, confidence is high. Name the movie. Name the movie that's from. There is something on your nose. noise. I don't have the compressor enabled on this mic. I can turn the compressor on. It does have a compressor, but compressors are a lot of dicking around. Just speak, don't spit. Yeah, it's in 45 minutes. You're going to miss it? Yep. Hey, Omar from Egypt. His beer could reach all the way to the moon. I'm telling you, like, it looks like he's from Led Zeppelin or something, you know. Yeah. Anyway, very cool beard, and confidence is high. So I am predicting a success, a complete mission success, based purely on that guy's beard, that mission controller's beard. I'm calling it now. Nova C is 1.5 meters diameter. Yes, it is. Here it is. Intuitive Machines. It looks like that. Is it the mission is IM-1? So the mission is IM-1, but the actual machine, the lander itself, is called the Nova C. So I think that's what it is. So yeah. So yeah, can carry power is 200 watts. Can carry 100 kilo capacity, and they've got all sorts of basically NASA. This is a NASA funded thing, but NASA contracted Intuitive Machines to do a lunar lander for various NASA instruments. So I think they're all NASA instruments on there. A good lot of them are NASA instruments. And yeah, so it looks like, where's it? There was a photo of it somewhere. Intuitive Machines. There was a photo of it in compared to a human. Anyway, it's pretty cool. There it is. There it is there. There you go. There it is. 4.3 meters. Yep. So it's pretty tall. It's pretty big. It's a pretty big lunar lander. What was the height of the Apollo lunar lander? What was the height? Does anyone know? Couldn't be much more than 4 meters, maybe 5-ish, 5 or 6 absolute tops. But it's a pretty big lander. So 4.3 meters, and look at those feet, those big pads. Yeah, confidence is high. It's a big phone box. Yeah. They didn't lose the Apollo technology. Everyone likes to say that. Oh, they lost it all. It's like, no, the documentation's still out there, but you wouldn't make things like that anymore. But no, there's millions of documents out there. Millions. What do you think, they have the CAD files? Doesn't work like that. Oh boy. Yes, it's a 3D printed engine apparently. So yeah, it's there we go. So this is one of the instruments. This is a teller. Yeah, apparently they plan to, like, I don't know if it's going to be live, but they plan to, like, they've got cameras on the things. They want to film the plume coming up and all sorts of stuff. Like, it sounds really good. I mean, this absolutely sounds like a fantastic mission. It's got lots of payloads that do various things. Update. There's an update from Beard Dude. Nominal. Nominal. Come on. I am enjoying the coverage. Coverage is good. Deputy Associate Director of something. Thank you, Pro Engineer. Lunar lander was 7.04 meters. There you go. I was a bit off. But yeah, okay, 7 meters. Yeah, that makes sense. Yep. There you go. Oh, 4.2 meters without landing gear. 9.4 meters with landing gear. Really? So it's actually taller than that. Oh, where is it? 4.3? No, I'm sure that would include, no, 2 meters. No, that didn't include the landing legs. Oh, sorry, the Apollo lander was 4.2 meters without landing gear, 9.4 meters with landing gear. But Pro Engineer says 7 meters. Okay, oh, it's bigger because it had to carry humans. You know, it had to carry 2 humans down to the surface. So it's kind of a big deal. Yes, of course you can't build Apollo anymore because it was done with inherent knowledge of engineers and workmen. Yeah, but there's there's millions of pages of documentation available. But yes, a lot of it was done with inherent knowledge of, the craftsmen that did everything, that put absolutely everything together. What is it, 200,000 people or something worked on the Apollo mission in some way, shape, or form. And yeah, it's just nuts. Can you share the audio? I thought I am sharing audio. You can hear their stream, right? Hands up if you can hear their stream. And if their stream is at a good level. You should be able to hear it. No, oh, you can't hear the stream, sorry. Okay. Oh, sorry. I know why. Yeah. Dumbass Dave. I'm getting the audio directly. Streamlabs gets the audio directly from here. I need to switch over the microphone to XSplit audio. Boom.
So we're
now we're good.
Yeah, a demonstration
Check.
totally in action.
Check.
So just very briefly, there are 2 other
Check.
Tech demos on this mission. Can you cover those very quickly?
I can automatically adjust mic volume. There you go. How's that?
Frequency masking,
How's that?
Is to try to get a measurement of
how's my audio and their
on
audio? There we go. Yep, you can hear now. Good job. Yep.
Low gravity is the
sorry, I just
settle down.
Oh man,
like in a car,
very low volume. Really.
You can measure it easy.
Cooking with gas, very low volume, too low. Okay.
So we know how much propellant there really is. And then the other one is scalps. One of the things that as it lands, the thrust is going to throw up all
Is my volume too low or is their volume too low? I've turned up their volume.
So we have 4 stereo cameras that are going to take images of that and get data so that we can improve our modeling so that in future landings we can make them more safer and things like that. So we're using that as a technology.
My audio should be a bit louder than theirs.
To make them more safer.
Well, thank you so much, Prasan. It's really been great speaking with you. Really exciting stuff. And for now, we're going to send it back to Gary and Josh.
Hey, thanks, Leah. Nova C is a little less than 55
Their
kilometers
mic
from
in
the lunar
comparison with my
surface
mic.
and about
Good
20
check.
minutes
Yep,
to
that's good
powered
levels.
descent initiation.
Okay,
a
good
critical
enough now.
maneuver that marks the beginning
Yep,
of Nova
okay.
C's final
You're gonna have
moments
to be happy with
before
that,
touching
'cause I
down
am
on the lunar
maxed
surface.
I
It's
am
no
max
secret that
volume
landing
on the stream.
challenging. Countries around the world have attempted
Max
this
volume
incredible
on the
feat,
stream.
some successful
Max volume
and some
in
not.
XSplit.
Of course, the United States
This
has
is quite
landed on the
complicated.
moon
I'm
many
feeding
times,
this
most
from
notably during the
this
Apollo
screen
program.
into
But this
XSplit,
may
and
be
then
the
XSplit
first
is
landing by
providing
a
the stream to
U.S. commercial
StreamYard,
company
which
enabled
is then
under NASA's
providing
CLIPS
the stream
initiative.
to multiple
Ahead of these important milestones,
things. So,
let's discuss
yeah.
the challenges of landing on the moon
So
through
I can
CLIPS.
automatically
Take a look.
adjust. I've got automatically adjust mic volume on, or I can manually
Landing
do
on
it
the moon
now.
is hard.
Check.
We're going back. Under
I'll
this
keep
Artemis
automatic
program, we're going to be sending humans to the moon for the first time since Apollo. So ahead
time.
of humans, we want to get up as much
Yeah, this is the
science
first
exploration and
NASA
technology
mission to land on the moon
as possible.
since
So
1970.
CLIPS starts facilitating a lot of the early science,
Since,
the things we want to learn
1972.
before we even send humans. CLIPS stands for Commercial
Since
Lunar
Apollo,
Payload Services,
17.
CLPS.
The services part is the key element. Ordinarily,
And I have
NASA
personally met
delivers a
Gene
payload to
Cernan,
the surface of the moon.
Apollo
They do it
17.
with a commercial partner, but NASA
and also Apollo
controls the
10.
building of the vehicle.
Been to the moon
Now,
twice.
providing the service of
Yes,
delivery
I
of
have
our
met,
lunar payloads to the
shook
surface
the
of
hand
the moon.
It is a delivery
of
service
the man
akin to a
who was the
delivery
last to
service
set
that
foot
you
on the
have
moon.
here
Sadly,
on
he's not
Earth.
with us
NASA will
anymore.
provide payloads to a commercial
And
company.
like,
They decide
when
how
you
to get
meet
it to
one of
the
these,
moon. They have to
like,
develop their own
you,
lander, but they
you
also
shake
have
the
to
hand
manage
and
the
you go,
entire end-to-end
this guy has
mission.
the right stuff. You know,
To
like you can feel it. It
provide
oozes out of
affordable,
them.
rapid,
Even when they're
frequent
old, it's
access to
really
lunar
like
surface
it's really
through
amazing.
American
It really
companies.
is.
We're funding different companies.
We have commercial companies that
And he was an
are
engineer too,
competing to win
because they were all
task
engineers.
orders to
Every
deliver our
Apollo
payloads
astronaut,
to the surface
with
of
the
the moon.
One of
exception
the goals when we
of
started Eclipse was to help establish a lunar economy.
Somebody
Harrison
has to do
Schmidt,
it first.
who
Then
was
it
a
becomes commercially
geologist,
available.
not an engineer.
Then they're able to crank them
So
up.
they're
Then
all
able to
engineers. You
make
had to
it more
have
affordable.
you had to
And
have
so
an
the lunar
engineering degree
surface
back
is
then
just
to become
the
an
next
astronaut.
frontier for commercial environments.
But
Yep.
we had to acknowledge up front, all the way through the highest levels of the agency leadership, that some of them will fail. These missions may not be as successful as a traditional NASA mission.
We have accepted the risk that going through this innovative approach with these commercial
Conspiracy
companies,
theory in the house
that there
already.
could
They're
be
all
some
high-ranking
failures.
Masons.
Some of them are new companies. None of them have
No, it
ever
hasn't landed yet. I think we got like
successfully
30
landed
minutes
on the
left or
surface of the
something.
moon. So they're going to learn lessons.
We need to give our
Yes,
vendors
yes.
that
Gene
kind of learn.
Cernan was a
And
good
so
top
that'll
low,
help
top low.
ultimately buy
Gene
down the
Cernan.
risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads,
I
get
actually
to
spent
the lunar surface and land
more time with
safely.
him
They've been
than
able to
everyone
demonstrate
else
that they have
at the meet and
very,
greet
very good
because
technical depth and the ability to design and execute missions.
because like we're having like there was a photographer there. There was an official photographer taking photos. So you know, if you got the meet and greet package, you can meet Gene Cernan. And the camera failed. The cameraman had a problem with the thing, you know, camera. So we had to fix that. And so yeah, I got more time with Gene. And yeah, Space Cowboys, great movie.
Every one of them is doing what they can in order to have the most successful mission
You're an
possible.
idiot,
But the
Gunga.
important thing to realize is that risk tolerant does not mean risky, and the rewards are a long-term ability.
When will
to
be the
get
next time
payloads to
someone
the
sets
moon
foot on the moon? Well,
inexpensively, frequently,
confidence
and
is not
We
high.
want
It's
science,
not
so
high
we
with
can
Artemis.
then put more of our resources on even
Yeah.
more science.
Hey,
exploration,
Mike's
and
electric
technology
stuff
payloads
is in the
and
house.
get
I
more
bought
of a
some
return on
intuitive
investment
machine
when
stock
we get to
last
the
week.
moon.
I'm up
Eclipse
4.5k
provides
so far.
tremendous
Fingers
benefit
crossed.
across
Oh,
the
nice work,
scientific
Mike.
and economic communities.
So there's a lot we
Nice
got to learn
work.
about the moon to help
You're betting the
human
moon.
habitation and
Mike's
prepare for
moonshot.
missions to Mars and beyond.
So the moon is
Mike's
the first step.
financial moonshot. There you go. Great stuff.
The teams here in Nova Control have been working diligently over the past 7 days to take us this far.
I didn't
and
know they
are
were a public
laser
company, so
focused
there you
on
go.
the operations ahead.
Awesome
We're
work,
following
Mike.
the clock
Hope
down
it
to the
goes
start
work
of those
for you.
autonomous
At 30
operations
minutes
of Nova
left.
C, starting with
Yeah,
the powered
confidence
descent
is high.
initiation.
I repeat,
For now, we're
confidence
heading back
is
over
high.
to Leah Cheshire, who's standing
Where's
by
Beard
with NASA's
Dude?
Associate Administrator. Leah.
There's another camera in
Thank
there.
you,
Where's
Gary.
Beard
I'm
Dude?
joined now by Jim Free, NASA's Associate Administrator. Thank you for joining
No,
us, Jim.
confidence is high
This
with
is a big
the
day, and what are some of the challenges to
SLS
landing on the
rocket.
moon that
I'm
people
totally
might not expect?
confident
Well,
in
it
the
is a big
rocket,
day, by the way.
but
Yeah, you're right.
the
I
mission,
think
the mission
the challenges
profile,
are
and the fact that they
multifaceted.
don't
First,
have a
getting
lunar
into
lander yet,
lunar orbit
and they
is
they
a
were betting it all
challenge.
on
Going to the
Starship
South Pole
to
is
land on
different
the
than
moon,
going
and
to
that
other
was like,
parts of the lunar
I don't know.
surface. The lighting
You know,
conditions are a lot different.
that's a
than
real
at the
long shot,
equator.
and then
So
they
you have,
then they're
your
hedging
hazard
their bets on
detection
that
has to
now,
be a
but
little
still,
more reliable. You have
it's
to be able to
I
do
don't
that
know.
last minute
Anyway.
avoiding of the hazards that are
Dollars
on the
Lunar,
surface
there you
and
go.
finding that right place to set down, so
LUNR.
you're also level or within a tolerance that you can be for level on the surface.
We've talked a little bit about how this is
Whoop,
a different model for us. So how
Okay.
does NASA help
Oh
ensure
yeah,
success?
yeah. There we go. Bumped
while
up
we
when it got
also
so.
allow
Oh
these
yeah,
companies to figure out
it
their
jumped up.
solutions?
Geez, you could have bought
We're able to
at
offer
$2.
our technical expertise, so
Or
companies can ask
just over
for
$2,
technical experts
say an average
from
of
NASA that might
$2.50,
be an expert on
and,
lunar surface conditions, or
it's now $11.
orbits
Well, it jumped
around
up
the
to
moon,
$11,
or
and
even
now
just
it's back
in
down to
assembly of the spacecraft,
$8.28.
the vehicles.
That's nice.
But they can
But
also
over the
ask for
last
help
year,
during the
it's actually
mission.
down
We
over the last year
provide help
in-
through our deep space
in
network to get the
intuitive
communications
machines.
to bring the data.
Yeah, they
back
were at a
to the
peak of like
control center here,
$23 or something.
to help them maybe understand their
Oh,
orbit better, or
they were
get more
$40
communication with the spacecraft
after
as
they
well.
first
So
loaded.
both
Really?
in
Is that an
advance of the
anomaly?
mission and during the mission also.
And CLIPS is just
$40,
one way that
and
NASA
then they went down to
is
$2.
using,
And now they're back up to 828.
Space economy. So
there you go.
what are some other ways, and why is NASA pursuing this commercial
it's
route
all based
for
on
complicated space missions?
What is it?
So we started back
sell the news
in space station.
What is it?
Where we started
Buy
with
the rumor,
commercial
sell
cargo,
the news.
where we
so sell, Mike.
investment in commercial delivery
I don't know
cargo
who
to a space station.
is
That's
who.
ported over
Can
into
someone
our
do a fact
cruise
check? Who
flying
actually said
commercially.
buy the?
We're doing that on the
whose
Artemis
quote is
program,
that?
buying things by service.
You
so
buy
that
the
we
rumor,
can
sell the news.
spur
Is that,
on
or have I
other
got that back to
investment
front?
that allows us to get our resources and use them elsewhere to do other parts of our mission,
I don't think I
exploring
have.
the moon or beyond.
You talked a little bit about Artemis for a
In
second.
Musk we
so
trust.
how does CLIPS
Down
fold
11%
into
today.
NASA's plans with Artemis? And
Well,
with this
yeah,
Move
if
to
it
Mars
lands,
architecture?
I
Mike,
could
I'd
talk
probably
about Artemis for
sell. You know,
hours,
and
but,
there'll be some a whole bunch of media
but
coverage.
Eclipse is
People will probably
absolutely
buy stock,
essential
and then
for
I'd
Artemis.
probably sell at that
It's our
point.
first steps
Then they
of
won't have anything
understanding
for
the
years,
lunar
and it'll just
environment. So
peak up and
the
then
Intuitive
yeah,
Machines lander is
tail
going to
off
help us
probably.
understand
That's
how
my
the
tip.
lunar dust moves as the rocket plume,
Not financial
the exhaust
advice
of the rocket hits
on the
that
EV
dust.
block.
We need to
Never listen
understand
to an
that
engineer
because
for
we're
your
going to
financial
land
advice.
even bigger landers with our humans in the future. And
Billions
we
and
want to land
billions
it
going to other
close our
countries.
other
Yeah,
elements,
NASA, here's
so
10
we're not
bucks. Yeah.
blowing that dust
bloody
everywhere. How
ridiculous.
does it behave?
Yeah.
So that's just
Unbelievable.
one
Thank you, Pro
part of
Engineer.
it, but it is our
In
first
fairness,
step of
Grumman were
understanding
working
that
on
environment that we're gonna put
finishing
our
the first
astronauts
lunar
on the
lander
surface.
until days before it was mounted on the rocket. It's not unprecedented.
But for now, thank you so much for joining
True,
us
it was
here
all
today.
like they
We're
were all
gonna go back to
one-offs,
Gary and
kind
Josh
of like
to
each
highlight
one
some
was
more
its own
payloads
thing, and
ahead
they
of the
tweaked
power
things,
descent
and
initiation.
like, oh yeah, it was very seat of your pants
Hey, thanks,
stuff.
Leah. A report at
incredible.
4:54 p.m. Central Time from the flight control team
26
shared
minutes.
that Nova C is less than 30 kilometers above the lunar surface and is
Do we
in
want
the
those
lunar
captions on?
southern hemisphere. We're still on track for PDI at 5:11 p.m. Central Time. Nova C will perform this maneuver to slow the vehicle's descent, then pitch over and scan the landing site for hazards, making
it's
any
gonna pitch
necessary
over and
corrections
scan?
in the final burns to ensure a safe landing.
Nah, it won't
We've
come down to
highlighted
there.
5 of the 6 NASA
Confidence
payloads
is
so
high.
far throughout our broadcast today. Let's talk about the final NASA payload, LN1. Lunar Node 1, or LN1, is a small
Sasa.
CubeSat-sized flight
I would
hardware
like to
experiment
experience
that
all of us
integrates
watching a manned
navigation
mission to
and
Mars together.
communication
Yeah,
functionality
I'd like
for
that. I think
autonomous
it's going to happen in our
navigation
lifetime.
to support future lunar surface and
My
orbital
lifetime,
operations.
anyway. So let's say, another.
Lunar Node 1 is meant to be a
Let's say
demonstration
another
of how
30
we
years.
can use various navigation
Yeah.
technologies to figure out where
think
you
it'll
are
happen.
in and around the
But
moon.
there won't be any Mars base.
I'm
Bullshit.
holding in my hands the Lunar Node 1 mass simulator. We use this build to test out our vibrational modes, put on a shake table, and also do fit checks with the lander itself. Inside of our payload, we have multiple electronics boards that fit within this chassis that is a little bit about a half a U in size. You can see our external connectors here where we have our data and power to the lander itself.
Nice,
And
good
within here, we
engineering.
have multiple boards that do the power regulation, our data control, our FPGAs, all those kind of electronics pieces are in here, as well as a small S-band radio that attaches up underneath this top radiator in order to distribute this heat, and then to talk to the antenna, which mounts here. This is the same size and build as the flight payload. It's just not covered in MLI or some of the other materials that you'll see on the flight build itself.
So what does that one do? Sorry, I missed it. So did anyone catch what that little QB did?
LN1 will test a lunar navigation concept of operations with the implementation of MAPS, or the Multi-Spacecraft Autonomous Positioning System. Ideally, this kind of technology can support a network of communication and navigation amongst local surface and orbital operations.
Yeah, because one of the
LN1
problems...
will test multiple navigation links from the surface of the moon back to Earth to characterize both MAPS transfers as well as GPS-like signals that could support a
one of the
future
problems
lunar
with the moon
communication
is
and navigation network.
How do you navigate on the moon?
Best things about
There's no GPS satellites up there
is getting
whizzing
imagery
around,
back.
right?
And Intuitive Machines has several camera systems on board, including Eagle Cam.
So they need a solution
it started
for
as
that.
a challenge from our
working on
CEO, Steve Altimus, to his alma mater, Embry-Riddle Aeronautical University. Students and faculty created Eagle Cam to take an out-of-this-world selfie of Odysseus landing on the moon. The camera system could capture the world's first ever third-person picture of a spacecraft making an extraterrestrial landing. The camera system is designed to deploy off of Nova C approximately 30 meters above the lunar surface and take images of Odysseus during landing. Additionally, the device will test a dust removal system, which could lead to the future advances in spacesuit technology. As part of this project for Eagle Cam, Embry-Riddle teamed up with NASA's Kennedy Space Center to demonstrate
sure.
The
Once we
NASA-developed
again,
electrodynamic dust shield, or EDS. EDS
it's
uses an
all a
electric
return on
field to
investment
remove dust.
thing,
The technology was tested
how many satellites
aboard
do you
the
need whizzing
International
around the
Space
moon,
Station,
and how long do
will
they
be
last,
the first ever
versus the value
demonstration
you
of
get in
EDS
them
technology
based on the number of
the
missions
lunar
that
surface
require
after
that
landing.
actual precision.
Intuitive Machines
So, and is
also
there
had
other way to
several
do it?
cameras
Other
on the
ways to do
lander,
it?
including wide and narrow field of view cameras. They started the mission with incredible imagery as the SpaceX second stage deployed our Nova C
No, the
lunar
Nazis
lander,
are on the
capturing
outside.
iconic
They're on the
images
far side of the
Earth
moon. The
after
Nazi base is on
separation.
the far side of
Requires
the
a
moon.
lot of planning, work, and
I've seen
just
the
a hint of
documentary.
luck. Payload Integration Managers programmed the lander's wide and narrow field view cameras to take 5 quick
How did they
images
unload
every
the
5
moon buggies?
minutes
They
for
had it
2
on the
hours,
side.
starting 100 seconds after
Yeah, they had them
separating from
folded up,
SpaceX's second
fold them
stage.
up on the side. It
Out
was
of
sort of
all
like
of those images
on the
were
side
taken,
of the
we
landing
ended up with
part
just
of the
4
lunar lander,
inspiring
and
ones to show
yeah, it's
humanity's
sort of like
place
folded
in the
out,
universe.
folded down, and
Right
sort
now
of
we're
out.
a little more than
and then
10
they drag
minutes
it
from
in, and then
powered
the wheels
descent
pop out.
initiation.
Yeah,
Let's
it
go
was
to
all
Leah Cheshire one last time for the final
all
interview
folded up.
ahead of this critical maneuver. Leah.
Iron Sky. Yes,
Thanks,
best
Josh.
documentary
I'm
ever.
here now with
If you're
Nikki Fox,
looking for
NASA's
the
Associate
best, the
Administrator for
absolute
Science
finest
Mission Directorate. Thanks so much for joining us.
documentary about the moon.
It is a great day.
Iron
and you're
Sky
watching this with
and
leaders
Iron
from
Sky
NASA
2.
and Intuitive Machines, just very close to
Highly
here.
recommend it.
What's happening in
Today's
the room
movie
right now,
recommendation,
just before
Iron
these final
Sky.
descent maneuvers?
Oh, there's just excitement, anticipation. You know, everybody knows landing on the moon.
No, there's not Chinese bases on the far side.
And
They're
we're
Nazi
already
moon bases
because this mission
far
is
side.
already a success. You know, this is we've launched.
No
we had a
Bigfoot,
beautiful
but they do
launch.
have dinosaurs.
We've taken great science data all the way. Every single challenge, the team has really.
I do
risen up and
believe the
solved
Lunar
it.
Reconnaissance
And
Orbiter
now
is
we're in
still
lunar
orbiting.
orbit, you know, minutes away from
So
starting
can anyone confirm
our
that? I
descent
believe it
down
is.
to the lunar surface.
I wonder
So
if they're
for
going to
me,
try and snap a photo
so
of
many
it. So
successes
like,
with
it's
this mission
probably
already,
too
so
small to
just a lot of
capture, but
excitement.
I'm loving that.
maybe
so
not.
we are working with
No,
these American
no,
companies
no, you
in a
should be able
very
to get a
unique
couple of
way.
pixels.
These are challenging
I think.
goals, and some people would probably consider this a bold endeavor. But what does it mean to you when you look at
Because the Lunar
pursuing
Reconnaissance
challenges
Orbiter
in a bold new
can
way?
see the
I mean,
lunar
you're
rover
right.
tracks,
It is bold.
for example.
It is a
I've
new
done a
way
video
of
on that.
doing science. It is a partnership with totally new companies who haven't done these things before, and we are partnering them.
Moonfall,
with them,
yes,
and
I've seen
they
Moonfall.
are taking our science. It's a way for us to get more science and more
it's
technology
kind of okay,
to the moon quickly.
you know.
So it's faster, it's very cost effective, it's very
all right. They
efficient.
set it up for a
We're
sequel,
on our way.
and the
We've
sequel
got the
never
6
happened.
payloads from
It
NASA.
could have been
and
better,
we're
but
excited to get them down
you know,
there.
it's
With
worth
every
watching,
new
I
thing
guess.
we do, there's always a challenge.
Just
there's
for some
always
giggles,
risk.
shits and
This
giggles.
is a high risk but super high
Moonfall
reward. It'll
is a
get
shits
tons
and
of
giggles
science on
So
the
it's
surface.
shits and
And
giggles.
for my NASA science, this is exciting because our Artemis
Yes,
missions and our
confirmation
lunar
the
science
LRO
touches
is still
all
in
5
orbit, yep.
of our science divisions in very profound ways. So super excited.
You said high reward, so I want
There
to talk
is,
for a
there
minute
is.
about the
Beard
valuable
Dude.
scientific
There
insight
you go.
that we can get
Beard
from the moon.
Dude.
What is that? What does it
Can
mean
somebody
for
find
NASA?
out Beard Dude's
I mean,
name?
there's
Can
so
somebody
much we can do on the moon.
try and find
particularly
out
where
Beard
this one
Dude?
is going down to the south
I'm going to
pole.
screen capture that.
We're going to find great volatiles down there. So as we get prepared to send our astronauts
There you go.
there, then we know that there's water there, and we can
screen
use
capture.
that water. Water's very heavy to carry, so it's
I
really
am
great.
confident.
If you can use it on the
I'm-
moon.
I'm gonna post
we
that
can break
now.
it up into hydrogen and oxygen, use it for fuel. Really great for our
I'm
sustainability.
gonna
but
tweet that
also,
now.
where they're going is one of the oldest regions of the moon, about 3.85 billion years old. So we can actually learn about what
I'm
our
100%
solar system was like
confident.
before life started. Life is very noisy. We're very, very
The
noisy here on
IM-1
Earth. The moon is just like
moon
pristine,
landing.
and so we can really do some amazing science.
I look forward
work.
to learning more about it. So any final words before we wrap it up?
Based
Just
purely
thank you. I mean,
on
literally,
Beard Dude.
thank you. This is such an amazing team. You know, thank you to the people
I'm
that put the
100% confident
science
the IM-1
and the
moon
technology
landing
experiments
will
on
work
with us.
based
Those
purely
teams.
on
Thank you to
Beard
the
Dude.
commercial teams
So-
that put their instruments on and are riding with us. Thank you, of course, to Intuitive Machines for this just beautiful,
Intuitive
beautiful
Machines,
lander.
IM-1
And thank you to SpaceX
moon
for a
landing
beautiful
will
ride
work
to
based
space.
purely on Beard
It's
Dude.
such an incredible effort.
I'll
All
capitalise
one, I don't know, I'm a
Beard
big bundle of emotion. Go
Dude.
NASA, go Clips,
You'll be
go
known as
OD,
Beard
go
Dude.
Intuitive Machines.
I'm with you all the way. Thank you so much for joining us here today. Now we are following Intuitive Machines
go.
flight controllers during Nova C's
Tweeted.
final descent. So back to
I'm
Josh
confident.
and Gary.
Thanks a lot for that, Leah. During that interview for folks at home, we did hear that there was a maneuver to burn attitude, which means the lander is starting to make the positional requirements needed.
Okay. So
and we're going to start listening into the IM1 channel so folks at home can hear. We just heard from Flight Controller about 5 minutes
Yeah, they've got lots of different camera angles.
2 to 10 kilometers.
Beard dude is on the bottom.
1,100 kilometers.
Right there.
TIG being time of ignition, so we're inside of 5 minutes.
TIG minus 5 minute deadpans.
TIG minus 5 minutes. We are standing by for powered descent initiation.
Oh.
Gary, this is a critical 11-minute burn
Powered
to slow
descent
the
in 5
lateral
minutes.
velocity such that Nova-C can pitch over for further operations. And while we were in that interview, we did hear that the main engine gimbal checkout was
Dave knows
completed.
people, yes.
So now we're focused on the operations with Nova Control. For folks at home, we are listening into the live channel there.
That's right. A lot's happening in Nova Control. We're going to be hearing these status calls periodically as we follow the flight control teams that are monitoring Nova-C's descent towards the lunar surface. A lot's happening, Josh. Of course, we have this 11-minute burn. We're focused on the propulsion elements of this PDI. At the same time, the spacecraft is oriented in such a way that it can use a technology called terrain relative navigation
Old Norse
to scan
poetry
the
in the Viking
environment
Age.
along the way. What's happening there?
Right, so we know that we needed terrain relative navigation, that when we were descending and coming down to the lunar surface. Now, this involves two pieces. You have a camera, and you also have a laser rangefinder. At the top of the show, we started talking about, hey, the laser rangefinder,
the Indian lunar lander. I did do that one live. I can't remember much about it apart from the speeches afterwards were painful.
2 of the laser beams from NASA's NDL payload, make the software patches required to reassign those lasers into the TRN and HRN cameras in order to give us an opportunity to land on the south pole of the moon today. Gary, is quite the feat and challenge to overcome in just about 2 hours, because we elected to delay that orbit and go into another orbit. That's why the show was a little bit later. It appears to be paying out. The last call-outs that we heard,
Gary, have to pre-process it to ensure that
beginning processing optical images, and that was nominal. The last time we heard that was just about 20 minutes ago.
The status checkouts of these critical systems are essential to understanding the performance. The folks you see now on your view, this is Nova Control. They're monitoring every step and all the data coming from Nova-C ahead of PDI, which is scheduled just a little bit after 5:11 p.m. Central Time. Exactly what are these folks looking at, Josh?
Yes. Well, right now everyone's looking at their assigned screens, and all of them are tailor-made. Generally, there's a few who are looking at the same type of screen, but they're tailor-made for their task. You have Spark looking at electronics, things like how hot are the electronics. Payloads are monitoring different parts and pieces. In
5 degrees to burn attitude.
5 degrees left until burn attitude. The vehicle's still getting ready for this PDI ignition, which we expect here in just about
and a big Earth table
2 minutes,
in the middle.
Gary, 2 minutes.
Is that an Earth table?
So everyone's looking at their screens and doing their respective jobs
well,
and reporting up into the mission director, while the activity director is keeping in touch with everybody. There he is over there. Can anyone work out what that says? Putting this whole thing together.
Press started.
What's Beard Dude doing?
It's a call for tank press started. Just a little bit before that, Gary, we did hear that they were working on the cryo fill. So these are all steps that are leading towards PDI, powered descent initiation. We expect that to take about 11 minutes, where we're slowing Nova-C's velocity approximately 1,800 meters per second, and that's required to get this lunar landing opportunity in just a few minutes.
90 seconds to TIG.
Yeah, 3D printed engine will work.
All right,
Beard
90
Dude's
seconds
on it.
until we begin that propulsive maneuver. Again, power descent initiation is about a 10 or 11-minute burn that will slow the spacecraft's descent. A lot's going to happen after that 10 minutes, Josh. This is a single continuous burn. After that, we're going to see a lot of events in rapid succession: pitch over, vertical, and terminal descent.
1,800 meters a second.
And we just heard another call out from the prop console saying that feed line prep is complete. What that means is Nova-C's propulsion system, that mixture of liquid methane and liquid oxygen, that feed line is prepped, getting ready to go into an injector to blend those two propellants, and the propellant and the oxidizer, and have ignition of PDI. We're tracking that in just under a minute, Gary.
Converging on burn attitude.
Lander is getting into the correct attitude required.
Line prep complete both sides.
Another call for feed line prep complete for liquid methane and liquid oxygen in preparation for this PDI burn.
The screenshot dude. Another screenshot. Beard Dude.
15 seconds, exec mode.
The 15 seconds to exec mode. We're tracking a little less than a minute,
I don't think the
until the
table's
time
the screen,
of ignition
no.
for power descent initiation.
It's just a table.
Settling.
Thank you, Pro
Ignition.
Engineer again. Sign above Flight Dynamics. His desk says Flight Dynamics. Thank you. There you go. So Beard Dude is the Flight Dynamics
coming
dude.
from our prop console, Rob.
Flight Dynamics.
GNC call on good control.
There you go.
Thrust to wake 1.5.
These are great call outs in between our prop console and our flight manager, Scott Tamblin, calling it as the data is feeding into the lander, which means we are continuing to have good communications. The lander is sending that back to flight controllers in Nova Control. Gary, something we prepared for, we planned on, is that loss of communications. And that's why we have this.
Profiles on their website. I don't think so.
It's a good thrust control call from prop.
Good thrust.
But that's why we have this autonomous lunar lander. You know, we program, we know that, hey, we want to light PDI in this moment.
What is the radio
These are the steps
delay
you need
to
get
the moon?
there.
Does
But from
anyone
here
know?
on, this is an autonomous lunar lander,
3
and flight
seconds?
controllers are monitoring communications and
Each way?
tracking the progress right along
Or
with
is
the
it 3
public
seconds
right now
total
with us.
return?
Nova C has the helm. It is in control and is making the decisions necessary to ensure a soft landing. We heard
It's totally autonomous
call-outs
too,
about
I think.
thrust, full thrust right now. There is the ability to throttle that thrust, and we'll see that throughout the descent as the fuel tanks continue
Looks like we're not getting
unload
any
and we expel
graphics,
that propellant.
telemetry on screen. No, there's not, which is a bit disappointing. Where's the model? They
And
have
we
put
did
it up
have a
before,
few
I think.
questions come in about
I think there is a
how
model.
much
No,
gas
here we go.
get in
There
this
it is.
to slow
There's
down
the
vehicle.
simulation.
We
That's
wanna
the
remind
real
folks
time.
that this PDI burn goes
Commanded thrust 90%.
So
goes
they're
in
burning
just
at
about
the moment.
90% right on time. So it goes
Yep.
in at 90% in order to, if the lander makes a decision and says, I need to slow down more and make a decision to make a safe landing, it's able to add a little bit more oomph and make that decision a reality rather than just a
What has it got,
possibility.
5 landing legs? Oh, everyone was laughing. Was that laughter in the...
Fido, I'm showing 500 kilometers to target, but my display's a little bit stale.
That's the mission director, Tim Crane, calling about 500
director?
kilometers, but stating that
500 Ks
his
away.
information might be just a bit stale.
1,000 psi in the helium tank.
It's part of the reason we're showing this animation, Josh. Of course, this
1.28
is not
seconds one
telemetry
way.
driven. We're just showing you
There you
exactly
go.
what's happening. As we hear the calls, this information is relayed through the audio loops. Not enough bandwidth to do a live stream of this, so we're relying on the data that's being fed from Nova C to Nova Control.
Come on.
Yeah, that data is going into the flight
10
controllers,
minutes
and
is
what
still
you're
an
seeing on your screen
agonizing
right
amount of
now
time.
is just to give you an idea of the vehicle's attitude. You heard them talking about moving to a burn attitude. This is what
Should
we
be dash
expect
cams
Nova
on
C
it.
is doing right now. It is a
Everyone says
simulation
that.
in the large screen,
You know,
just to
like,
give you
I've
an
got my shoe
idea
phone,
of
and
what's
it's got,
happening
you know,
over
5
these
cameras on
critical
my shoe
approximate
phone. Why
10,
can't
11 minutes
it's,
of
you know,
PDI-powered
$100 million
descent
machine have
initiation, trying
at
to
least one
slow
camera on it?
Nova C down, bring that acceleration down to about
Doesn't quite work like
1,800
that,
meters
but,
per second. And there's some follow-on steps
the
after
Japanese,
that, Gary. It involves
was
pitching
it
over
Japanese
the lander
lander?
using that
The Japanese
gimbaled
lunar
engine. We
lander
heard
that
the
landed
maneuver to burn
that
attitude
flopped
followed by
over,
main engine gimbal
that fell
checkout.
over.
So they'll use that
Its
gimbal
little
to pitch
rover that
the
it
lander
deployed
over
was actually a
and start a
commercial
vertical
toy. You can
descent.
buy it.
This
It's
is
a
where we
commercial
start
toy,
getting a
and
little
it's got a
tricky as
commercial
far as
webcam
there's a
on it and
final
everything.
approach. It may
I'm
add
sure
a
they
few
would have tweaked it,
seconds.
did a
It
few
may
tweaks
add a
for
little
it,
bit of time,
but
but we
apparently
are
it's a
intended to land
commercial thing.
right around 17:24. That's 5:24 p.m. Central Time. But
Burn
know that there is
Attitude
some
would be a good
give
metal
and
band
take.
name, yeah.
We're also expecting,
Beard
plan
Dude to
for, and
front it.
train for a little bit of loss of
On
communication during
bass.
this process.
That's right.
He looks like a
And
bass
that
guitar dude.
communication is absolutely important. And part of the
He
reason,
can-
and
he
we've
can
been
play
stressing this,
bass
Josh,
for
is the
burn
autonomous
attitude.
operations of Nova C. Part of that is after it performs that pitch over maneuver,
400 seconds to go.
If they have telemetry, then they have video. Yeah, whether or not they're...
Fido, I see
I
TRN
don't know.
DPOS processing in flight.
But there are multiple cameras on this.
All
One
right,
of the
that
things
was the call that we
is-
were waiting for. That was our major problem we've been working on in this dynamic situation, is getting those images processed from HRN camera, TRN camera, which in this case, a
They're
dynamic
processing the
situation, we had to improvise a little bit and reach into those 2 laser beams from NDL, figure out a patch while we were in lunar orbit, just about
Whoa.
2 hours, and it sounds like we are getting good readings from those images. Absolutely
it, laser?
remarkable
They got
feat.
laser
We
calls?
also
What?
happened here, I think, was 400 seconds remaining. That was coming from Fido and Flight Dynamics. Sean Stewart working the console this evening.
there's excellent calls to hear. Hazard relative navigation is going to be used after the pitch-over maneuver. This allows Nova C to make some decisions and scan the landing site underneath it and make decisions in an area that calculates the terrain to make sure that it's landing in a safe landing zone.
Right, so we finish up PDI,
Oh, that's a laser
rangefinder. Use
rangefinder.
that
Okay,
hazard
that's what they're
relative
talking about.
navigation, a critical tool in order to land on the moon to make those decisions, right? There's no human eyes, human
Flat Earth
elements
table.
deciding,
They know it.
okay, I see the hazard, I need to steer this way, or maybe press the gas, press the brakes. This all happens autonomously, and this is a huge requirement and a great call out to hear about the HRN
Flight
camera
Dynamics is
system
Sean
and
Stewart.
processing those images.
Dude, is Sean
right now,
Stewart, is
I'm
he?
tracking
Thank you.
5:16 p.m. We expect PDI to go until about 5:21, 5:22.
300 seconds and breaking 1.
Or about 300 seconds to approximate
Flight
those
Dynamics
numbers.
lead at Intuitive Machines. He doesn't look like Beard Dude. That does not look like Beard Dude. I think you got the wrong guy. It does not look like Beard Dude. Unless he's got some really old photo.
Josh, after those final series.
Thrust to weight is 1.7.
Wow, he's been
Following along after
that guy's
those,
been at Intuitive Machines for
critical
10
maneuvers.
years.
Commanded thrust still 90%.
90% thrust. We'll hear those call-outs periodically. We started at full thrust, 90%, still throttling. And good performance on that engine.
That's a great call out. Two things there. Nominal performance on this engine as well as the helium tank. So what we haven't mentioned so far in the show is that the helium tank pressurizes that liquid methane and liquid oxygen tank. But in addition, it's also used for reaction control system. Those are the small spurts that you see at the top of the lander in the animation
no
that
helium
control
pressure,
the vehicle's attitude. So for things like landing on the moon, you really want to land at the right attitude. That way your antennas are facing back, direct line of sight to Earth, and you can get that ultimate confirmation once you do suspect that you have landed on the moon.
The antenna alignment is an important element of landing on the moon, Josh. We're expecting the high gain antennas to be pointed towards Earth to confirm,
photo on LinkedIn
but
is
there
very
may be a
different.
delay.
We are expecting some sort of delay. I had talking to the mission directors about how quickly we could receive a positive confirmation after this landing process is through, and there was some dispute over how long. The earliest was just about 15 seconds after we see timing of when the event is supposed to happen. So right now we're tracking about 5:24 p.m. Central Standard Time. So maybe anywhere from 15 seconds after that, maybe a few minutes, 2 to 3 minutes while we work to acquire that signal. Because as you mentioned,
here's Flight
the lander
Dynamics.
is going to a general
Here's
area.
Flight Dynamics, and that is not Beard Dude.
9 kilometers altitude call from Tim Crane. The lander is going into a general area that we say this is the general area we want you to fly to. It's using that hazard relative navigation to make better decisions about this is an area with the least amount of slope. This is an area that's free of boulders and other obstacles. So it's making autonomous decisions about where to go.
3 minutes to go. Breaking 1.
Yeah, that looks more
3
like Sean
minutes call.
Stewart on his internet profile. Oh no, sorry, his
Just to wrap that up, when
LinkedIn
the lander
profile.
is making those decisions,
so Beard
Gary,
Dude is not
it's
Sean
also
Stewart.
very difficult to track. We've been very fortunate thus far tracking communications to this point.
To wrap that up, Josh, 3 minutes, that brings us
Alright,
to
now I'm a believer
just shy
he's
of
being booted.
5:22 p.m. Central Time. We should wrap that up, Josh. The 3 minutes that brings us
Alright,
into
now I'm a
burn just
believer
shy
he's
of
being booted.
Then we'll begin the next series of maneuvers to get us towards vertical and terminal descent. It starts with the pitch over.
And just looking at our notes here, we did go into this burn expecting pitch over at 5:21 and 57 seconds. So good call out on the timing of that maneuver. It's important to remember PDI starts an engine burn
Flight
that
Dynamics
does not stop until landing.
That is not
so this is a
Beard Dude.
throttable liquid methane,
I think
liquid
Beard Dude's over
oxygen
there.
engine. We lit the engine at PDI, and while we are changing into a pitch over, vertical descent, and terminal descent, and then landing, that is a throttle down to the lunar surface. And when we do get out of PDI, if we hear that call of PDI complete good burn, everything after that is going to happen in very quick succession, Gary. The time it takes to go from pitch over to landing, or what we estimate landing to be, just looking at maybe 90 seconds is what we expect nominally.
3 minutes to touchdown.
There is some wiggle room. 3 minutes to touchdown call
3
from
minutes.
the mission director.
Come on, you can do it.
For an on-time landing, that sets us a little after 5:23 p.m. Central Time.
Right, our notes going into this burn, 5:23 and 25 seconds.
That's okay,
the
Pro
autonomous
Engineer.
operations,
no
Josh sets this to a
definitely
clock.
not flight
this
dynamics.
Is exactly
He's doing
what we got
else.
relayed before the start of our
Still
coverage
processing.
today. We're right on track.
DPAS, terrain relative navigation measurements.
Excellent call out. That solution that flight controllers were working so hard on
to
make sure HRN was working, pulling on extra resources that weren't originally planned for from those 2 laser beams from NDL.
Yes,
it appears and sounds like that solution is working, and the people working to patch that software were certainly under pressure. The clock was ticking as we went into that extra lunar orbit. It wasn't a situation where we could just sit in lunar orbit and try to solve our problems indefinitely, and it's sounding good so far on the call-outs.
2 minutes remaining till touchdown.
2 minutes to touchdown. That required a patch to be designed on the ground and uplinked to Nova C to confirm that those laser sensors on NASA's navigation Doppler lidar could be routed to the terrain relative navigation and hazard relative navigation. That call out is fantastic.
Fighter, do you have an altitude reading?
Right. All the systems are working, all the nav and landing systems are working together.
Standing by to see if we can get an altitude reading from Fido here. That's Flight Dynamics Officer Sean Stewart on Blue Team.
Yep. Blue Team. Come on, 1.5 minutes left. Engage clench actuators. It will be amazing nobody has a cowboy hat.
Confirm
oh, they in Texas, are they?
Gimbal.
Cool.
Sounds like we have some data that confirms pitch over. This starts the HDA process. That's hazard detection avoidance throughout this show. You've heard Gary and I talking about the problem that was attempted to be solved in lunar orbit, making the decision to not only postpone this show.
NDL indicates altitude of 1,000 meters.
1,000 meters.
1,000 meters call out from NDL. That is coming from flight management. This is a system right now. NDL was not intended to be the primary landing system on this. Instead, we're using 2 laser beams from NDL and feeding that into that hazard detection and avoidance system that you see on your screen right now, with the lander making autonomous decisions about where it wants to land. That is generally
less than 1 minute remaining.
Oh, okay, so they were a bit out, were they?
Less than 1 minute remaining for touchdown.
Activity director.
And again, that's the time of touchdown.
Here we go.
It may take some time to actually
6
confirm
feet,
the
last
status
1 meter is the one that kills you.
In this process, we do have a deployment of Eagle Cam attempting to take the third-person images of Nova C going down to the lunar surface. We are inside of 1 minute, Gary.
Come on. Come on.
Yes, we're well in the blowdown.
Where's the timer? I guess they're not that accurate, right? I think they're just like 10. There's got to be 10 seconds left.
And we're tracking here in the broadcast booth. The clock has reached the expected.
May take a minute for comms to reestablish standby.
Yep.
There it is, mission director beating us to it. We've reached the expected time of landing, but now is the process of waiting for comms, and we are in standby mode, as you heard it from the mission director, Dr. Tim Crane.
But they don't know yet. Because it was autonomous and wasn't that, and their time is not that accurate. They're just waiting for a call back from it. Come on.
And 1 minute has elapsed from the notes that we have, Gary, of that original burn starting at PDI.
And you have carrier lock.
Carrier lock?
That's MD asking if we are getting the ground stations locked on to Nova C.
Yeah, it's definitely landed one way or another.
That carrier lock call, Gary, we expect that to come from GroundNet or COM. That conversation possibly not happening on our public channel that we have access to. We're just standing by to hear that come through the channels as we approach almost 2 minutes since we estimated the landing time. We did get a few call-outs on the side, folks coming into the room saying there was about a 2-minute forgiveness in our timetables.
2-minute forgiveness.
We were checking our antenna reception.
Checking antenna reception.
Come on. It was doing perfectly. Everything was nominal. Yep, beard dude's looking over. Beard dude's looking over. Come on. Moon is a harsh mistress. Indeed. Finger dude. I think he's secretly praying.
And we're standing by, Gary. We're standing by just as we approach 5:26 p.m. Central
Deathly
Standard
silent,
Time.
yeah.
Given those mission directors' notes of the flexibility between what
Oh,
we were
he's
tracking,
sucking
what we
it
were
in.
given was just about
Guy on the left there.
5:24.
All stations, this is MD. Please look back through your logs and confirm the last information you had, and we'll determine this is a comm outage.
And that's the
Oh,
mission director,
okay.
Gary. These are our notes
There's
here
the mission
of what
director,
we believe.
bottom
We talked
right
about
there.
the comm outages with the lander making autonomous decisions. This is the process of going through the last bit of data that came into Nova Control and working to verify, okay,
So,
this is the
okay,
last
we have
bit
no
of data.
comms.
Where was
It's landed.
was the lander possibly going?
One
How
way
do
or
we
the
look
other.
for it and establish those communications? Nova C uses 4 antennas placed at the top of the lander that are
General
designed
Zod
to
bent the
capture
antenna
these
over.
communications. But we did expect this. We talked about it, that this is a communications challenge in it of itself, and right now we're standing by to hear that communications call out.
Check out the NASA chat. It's all F in the chat.
We're just a little more than 3 minutes from the time of when the clock reads 0 for Nova C landing on the moon.
Damn. Maybe they're using AT&T. Damn. Come on. It's landed. That we can be 100% confident of. Worst time for a Windows update ever.
And we just checked with our team here in the broadcast booth, decided to let's stay on this. All the chatter we are not hearing on this public channel, Gary, all things indicate that we are working to solve a possible communications challenge in this moment. So we're going to continue to stand by.
It's not that unbelievable, Roderick, that they can't do it in 2024. It's
yeah, I guess
it's really hard.
Polled the
Landing on the
room
moon is
looking
hard.
For states,
Really
and
hard.
we're going to go ahead and cycle the ground transmitter on Goonhilly and do some RF sweeps. Is that your plan?
That's correct.
Right,
Roger,
so there's
copy.
cycling the
And that's
receiver,
just what we
transmitter,
had in
receiver
mind
on
in our notes,
transceiver
Gary, is
on
that if we
at
encounter a
Goonhilly in the
communications
UK.
challenge, we mentioned how difficult it is
So they're
to
turning
land on
they're
the moon
switching
and
the power off and
continually
on again.
have those communications.
At
What you
the-
just
at the
heard there is
receiver
folks talking about
station at
using the
Goonhilly in the UK.
Goonhilly Earth Station Limited dish in the UK
Lock the
to
doors,
do a
says
sweep
Mike.
looking
Lock the
for
doors,
that
Mike.
signal.
Sell.
We mentioned
Sell,
that
Mike.
autonomous process of the lander reassigning itself somewhere that it believes is safe. Going into it, we heard that
Mike
the
is-
HRN camera was
Mike's electric
functioning
stuff is
and
frantically
able to
selling
make
his
those
shares in
decisions after
Intuitive
what was a
Machines.
2-hour orbit of problem solving with Intuitive Machines'
I'll buy
TRN
back in. I
and
think I'll buy in.
HRN cameras, the laser rangefinders assigned to those are the ones that Intuitive Machines installed inside the navigation pods. The laser rangefinders were not activated. We went to NASA and asked to use 2 of the laser beams on the navigation Doppler LiDAR.
That's right.
And spent 2 hours in orbit.
Team, we're going to confirm our pointing vector with our antenna for
Yep.
post-landing.
Yep.
All right.
We spent
Could
about
be on
2
its
hours
side.
in orbit to solve that problem. We got good readings on the way down. And right now, we are working to confirm communications on the surface of the moon, roughly around the Malapert A region.
There was no
That
live
is the
feed.
South Pole region
Wig
of the moon.
Manded? Was there a live feed
That's right.
somewhere?
What we do
I'm sure
know
they would have
is the
showed
power
it,
descent
shown it on
initiation. We were
NASA.
following along in the status calls. We executed a pitch-over maneuver, and we're counting down the clock to a landing time of 5:23 p.m. Central Time. Well, Josh described those processes of working on the
Step
communications
one, aim
component to
antenna at moon,
confirm
yeah.
data from the lander, pulsing the teams surrounding him to check the status of Nova C and the data that they were receiving
Mike
here
says
at Nova
after
Control
hours it dropped. Oh yeah, because
to
the
confirm landing.
share market's not open at the moment. To be after hours. It dropped $1.50 in 2 minutes. Right.
Fido MD on IM1.
QMD.
I'm looking at our phase plane there for the.
I mean, it could be a comms issue.
Looks like we had excellent pitching.
Could just be a comms issue, and it could be sitting there happily transmitting away.
But it did see a little bit of a roll excursion. Could it be that we landed off angle and roll in the final phase?
So I do
off angle and rolled.
We had up to an 8-degree excursion. We're about to begin the roll maneuver, which is about
terminal phase.
The terminal phase, which is a large roll maneuver to get to landing attitude. That's the last data point I have.
Well, they're always an expensive fail.
We were really solid.
Right, so terminal phase begins at 30 meters.
Antenna-rich exhaust.
Or post-HDA.
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 400 meters.
Very good.
And that's a great conversation confirming.
That's good ground network, good for box scan. Make that go.
Yeah, that was good confirmation of the process that we were very familiar with, talking about the attitude of the lander, making sure that those antennas are within direct line of sight with Earth stations, ground stations on Earth, excuse me.
Mission director at all stations are also updating our pointing vector with our dishes to make sure that they're tuned in on our final landing site.
There's a caller searching for that communications back to the ground station. This one particularly is in the UK that's tracking us. And it's important to note, Gary, that we have an entire network dedicated to working these communications problems. It's been active this entire mission. And the largest, most powerful dish out of all of them is about a 64-meter dish in Australia. That time to search with that opportunity with the largest, most powerful dish, we're looking at about 12 to 13 hours after our estimated touchdown.
Right, so
this is a process that we could be looking and searching for the lander's signal for confirmation for quite some time, but we're going to continue to listen in and stand by as our flight controllers are working with the ground station in the United Kingdom to work this issue, work this problem. It's another challenge, very similarly to the challenge solved, just to make it this far.
Science of life, we have a return signal we're tracking.
They have a return signal? They're tracking? What? Work the problem, people. Let's not make things worse by guessing. The thing about situations like this is that, you know, it's whatever happened has happened.
We have an onboard fault detection system for our communications that after 15 minutes with lack of communication will power cycle the radios, and then
they'll literally turn the power off and on again.
15 minutes it will then switch antenna pairs. So we have some time here to evaluate. We do have signal that we're tracking, so we'll see what happens.
They do have some sort of signal.
There's a great call out about the autonomous systems installed on our Nova C-class lunar lander named Odysseus. The process he's mentioning, Gary, is very similar to the one that we were preparing ourselves for at AOS, to where the lander has systems in place to recycle its antennas, to switch antenna pairs, and that was very similar to what we thought we were going to need to do after acquisition of signal. When we separated from the second stage of the launch vehicle, if we made it to a certain point, the lander was autonomously programmed to start taking matters into its own hands, and that was the information that our mission director, Dr.
We're not dead yet.
We're not dead yet.
We're also not dead yet.
We're not dead yet, says the mission director. He's in the bottom right corner there. Or the flight director or whatever.
And the key here, Josh, is patience. It's 5:34 p.m. Mission Director Tim Crane confirming that it could take 2 phases of 15-minute increments to confirm the status of the landing. So we could be here, and we'll stand by and monitor as Nova Controls to continue to work this issue.
Tense moments inside of mission control with the most qualified folks.
We're picking up a signal from our high-gain antenna and transmitter. It's faint, but it's there. So stand by, folks. We'll see what's happening here.
It's
All
there.
Right, we're going to continue to
there.
stand
It's transmitting.
by. Let's keep this camera on inside of Nova Control.
It's
it sounds like
transmitting.
we are getting some kind of faint
I
signal.
want to send a series of commands to reactivate, make sure we're transmitting to keep Aquasonics active.
We're still standing by. The last call from Mission Director Dr. Tim Crane was that we were getting a faint signal from Odysseus's high-gain antenna.
So we're getting it from the high-gain antenna, not the low-gain backup. Can somebody do a fact check on the antennas it's got? If you got the high-gain antenna, that means it's not like falling over. It must be standing up if you're getting it from the high-gain antenna, right? Because the low-gain antenna would be the backup that would probably use if it falls over or something like that. But it's transmitting. So, or is the high-gain antenna?
All stations, this is Mission Director on IM1. We're evaluating how we can refine that signal and dial in the pointing for our dishes. What we can confirm, without a doubt, is our equipment is on the surface of the moon, and we are transmitting. So,
we are transmitting.
Congratulations, IM team.
Well
see
done.
how much more we can get from that.
Yes, they landed. Well done. They did.
An excellent call from our Mission Director, Dr. Tim Crane.
IM1.
And over to our CEO.
It just wasn't the excitement.
If I could just pass on a few words to the entire team in Intuitive Machines at Superbab and here in the Mission Control.
We're on the effing moon, says Mike.
What an outstanding effort.
Share
I know
prices
this
went
was a
back up.
nail-biter, but we are on the surface, and we are
They're on the surface.
And welcome to the moon.
Don't know who they are, family,
Houston,
relatives, all looking.
Odysseus has found his new home.
Yeah.
An
they
excellent
landed.
call.
They did it.
And this is
Well
our
done,
team
Beard Dude.
of Intuitive Machines
full team.
mechanics and their
9/11.
families, their friends,
$9.11.
everyone who has sacrificed so much to make it this far.
Wow. They did it. Well done. Told ya. I called it. Beard Dude. Oh, they did it. Fantastic. But yeah, there's a comms issue.
How about that call, Gary? That was something
Wow.
else, a faint signal. Now it's time to work on refining that signal. But Dr. Tim Crane, our mission director today, making the call. Odysseus has a new home.
It shows the disciplines of the flight controllers in Nova Control. They waited until there was absolute confirmation that there was a signal, and then that was when they took the moment to celebrate. We saw that it wasn't just the individuals in Nova Control that contributed to the mission. The contributions to enable the success of Nova C's landing on the moon stretches far
on
and
this
wide.
channel.
We showed,
Bye
of
now
course,
I'm a
some of the
believer.
folks watching there, but really it extends even farther than this. A wonderful and truly amazing moment to celebrate. The U.S. has landed on the moon once again.
And to everyone, you mentioned it goes beyond just the folks that we saw on camera waiting and working through those tense moments, but their friends, their families, and everything it took to get to this point.
All their friends and families.
We're still expecting an image. We expect that to come down sometime in the future, especially as we look towards some high-resolution images. Let's go ahead and it sounds like we do have a message we'd like to cut to. Can we have that message special for our folks, our employees, and folks watching at home?
Hey, that's right. With Nova C landing at Malapert A, congratulations, like you said, Josh, are flooding into the teams that made this happen. Really sets a tone for the American leadership and the future of a strong lunar economy. So here's NASA Administrator Bill Nelson.
Here he comes.
On the 8th day of a quarter-million-mile voyage, a voyage along the Great Cosmic Bridge from the launch pad at the Kennedy Space Center to the target of the South Pole of the moon.
That was a great shot.
A commercial lander named Odysseus.
Yeah, they are on the South Pole, by the way.
Powered by a company
really
called
difficult.
Intuitive Machines, launched upon a SpaceX rocket carrying a bounty of NASA scientific instruments and bearing the dream of a new adventure.
How old's Bill Nelson?
A new adventure in science, innovation, and American leadership in space.
Yeah, I was going to say pre-recorded perhaps.
Aced the landing of a lifetime. Today, for the first time in more than a half century, the U.S. has returned to the moon.
Yeah, 50
Today,
years.
for the first time in the history of humanity,
more than 50 years,
a commercial company, an American company, launched and
71.
led the voyage up there. And today is a day that shows the power and promise of NASA's commercial partnerships. Congratulations to everyone involved in this great and daring quest at Intuitive Machines, SpaceX, and right here at NASA.
Yes, SpaceX launched
What a
it.
triumph.
It's a good partnership.
Odysseus has taken the moon. This
Fantastic.
feat is a giant leap forward
Anyone's better
for
than Biden.
all of humanity. Stay tuned.
Thank you, Bill.
All right,
Yeah,
thank you,
it has that
Administrator
pre-recorded
Nelson.
feel.
Again, Nova C
Agreed.
and the United States has landed on the moon at 5:23 p.m. Central Time today, February 22nd,
Does this
2024.
mean we have to stay using imperial
Congratulations to Intuitive Machines on the successful landing. Science and data gathering is already underway.
Maybe that's
and
the
will continue
problem.
for roughly 7 days
Somebody's
on the lunar
using
surface, activating
imperial units
payloads
to steer the
and
dish.
gathering important scientific data to help ensure future successes in Artemis missions. For more about NASA's CLIPS initiative, visit nasa.gov/clips.
Gary, it's
still
been quite a journey for all of us at Intuitive Machines. Thanks to NASA for the continued
He's
support
81,
to enable
okay.
today's successful landing, and of course, everyone at Intuitive Machines, their friends and family who made all of this possible. That will wrap up our coverage of Intuitive Machines' IM-1 mission.
Yes, he was a
Thanks
senator.
for joining us.
But he was also an astronaut. He has been up. That's it. It's done. Ta-da! Dude, I love the beep at the end. What's that? What have we got? These are the voyages of the Star Trek Enterprise. The Starship Enterprise. These are the voyages of the Starship Enterprise. Yes, he went through all the NASA training. He is a legit astronaut. Oh, there we go. Cancel. Okay, done. Awesome. Awesome work. Whoop. Okay. Fantastic. That's it. It's all over. Oh. Oh. No photos. Well, I guess we'll have to watch the, Still playing the music. What the heck? Guess we'll have to follow on the Twitters to get the updates, the photo. But they said they were getting a signal from the high gain dish, which means the high gain antenna, which to me means, you know, most spacecraft and landers and stuff, they have a high gain antenna and a low gain antenna. The high gain antenna is usually the dish, hence high gain, because it's a dish. So if they're getting a signal from the dish, it means the dish is pointed at least somewhere towards Earth. It means hasn't fallen over on its side, and you know, maybe it could fall over on its side and be accidentally pointing back at Earth. That's a possibility. But at least it's still working. It's still transmitting. It is transmitting something via the high gain antenna. And presumably the low gain antenna is not a dish, or it's a smaller dish, or it's a wider band, a wider area dish. So, it doesn't have to be precisely pointed. So yeah, but presumably if they're getting signal, they've got to be getting data. But maybe it's so down in the noise, but at least they can see something. And yeah, they'd be staring at their screens and you can physically see the little spectral response and how big the signal is in comparison to the noise and everything else. And they're getting something from the high gain antenna. So there you go. Fantastic. well done, NASA, Intuitive Machines, SpaceX for launching them. So it's a really good partnership. NASA, you know, doing lots of the instruments and everything, and presumably, I don't know if they were, how much were they involved in the design. I'm sure they were some way. They were reviewing it and whatnot. But it was designed by the lander was designed by Intuitive Machines, and it looks like it's a success. They've landed and they're getting signal. So I mean, if nothing comes of it, like if they can't actually extract anything other than like if they can't extract some images or something like that, then it's going to be deemed a failure, unfortunately. But I reckon if you got signal, you're going to be able to extract something out. I think that's just a given. So they're just positioning their dishes now, and it'll eventually switch over to Canberra. And Canberra will be doing the handling the comms with their big dishy. And yeah, we can do the Canberra, what is it? NASA, what is it? Skyview or whatever? What's it called? NASA, what's the name of the NASA webpage, which tells you where all the dishes are pointed? It's not Skyview, it's aha! It's the Deep Space Network Now, DSN Now. So they currently have. Oh no, it's in the UK at the moment. That's right, it's in the UK. It's Donhilly or something. It's Goonhilly in the UK, which I haven't heard of before, but apparently that's a facility there. And whether or not, is that owned by NASA? Because that's not part of the Deep Space Network. But then again, they're not in deep space. The Deep Space Network is, although it can do moon-based things, but the moon is relatively close. Moon is not deep space. So the Deep Space Network is designed for Mars, and probes and other, things that are out there. Although they do moon stuff as well. But yeah, not at the moment. So I assume keep a watch on Deep Space Network, which is there, and eventually I believe they said they were going to switch over to the big 64-metre deep space dish in Canberra. At the moment, that's number 43. That's DSS 43, and it's currently not pointed to anything. It's not. In fact, Canberra's completely down. There's no comms at all in Canberra. I'm quite surprised. Usually there's at least one dish in operation, but according to DSN Now, there's nothing. So turn off that music. Goonhilly is private, is it, Sean? That's interesting. Okay, is that where the name comes from? Hitchhiker's Guide to the Galaxy? I forget. Yeah, I think once they get the bigger dishes, I think at one point they said, yeah, they'll be able to, once they get the big Canberra dish on it, they'll be able to really extract some serious stuff. So, yeah. So I'd be surprised if they could not extract, get something out of it. I'd be very surprised if the only thing they get is a signal and they can't actually get any actual data, which includes, but really everyone wants a photo, right? Everyone wants a photo. So as long as they could get one photo showing that it's on the surface and it's upright, well, even if it's not upright, if they can still get a photo. No, but it's got to be upright. For the high gain dish to work, I reckon it is on the surface, it's landed, and the signal from the high gain dish. So, yep, it's got to be upright. So maybe they just need to send some commands to it and, do whatever. And yeah, it's just a comms thing. Interesting, huh? So there you go. That was success. Beard Dude did it. Well done. That's fantastic. Yep. Oh man, that was like, it was looking a bit grim there for a while. But they officially called it that they're on the moon. Because they know, right? If you've got the signal, if you point the dish to the moon and the signal's coming back that you expect from your high gain antenna, it's just that there's no data. We're sure this thing is on its legs. Well, that's what I said, Davey. It's the high gain. They've got the high gain, and they've got signal from the high gain antenna. So I presume the high gain antenna would not work if this thing fell over. It would not. There's no way it would work. Or maybe it could fall over, and if it's robust enough to survive falling over, and if the dish just happened to be pointed in the right direction, then maybe. But otherwise, The Dish, yes, another movie, which is a must-watch. So everyone, tonight you must watch, do a double of Iron Sky, best moon documentary ever, Iron Sky, and The Dish, Aussie movie, The Dish, fantastic. Pixar, it didn't happen. Unfortunately, that's going to be the thing for the share price, because Intuitive Machines is a public company, and Mike bought some shares in Intuitive Machine. I didn't know. Maybe I would have bought some shares too if I actually knew that. Yeah. But yeah, if they don't get pics back, no one's going to care that, they can post a spectral response. Look, we got a signal back. Look, there's a little thing there. And no one's going to care. Pixar, it didn't happen. For the general public, it's Pixar, it didn't happen. So, yep. So that's really cool, huh? Yes, you must also watch The Castle. You also must watch Kenny. Kenny's another one. Anyway, Beard Dude for a medal. I agree. Beard Dude. Somebody put his name up there. Sorry, I forget, but somebody actually had his name up there. I think somebody found him. No, they found his position. So anyway, yeah, very cool. So that's it. Thank you, everyone. High G, probably less than 12 dB lobe, 15 degrees. Yeah, I don't know. All your antenna experts. Go follow NASCOM1. Richard Stevenson, who works at the Canberra Deep Space Tracking Network. Follow NASCOM1. Or one word, NASCOM1. I believe that's his handle on the Twitters, the X's. And I'm sure he'll give us all updates on when they acquire signal of it and stuff. So, yeah, very cool. So, everyone, thank you very much for joining. It's a winner-winner chicken lukewarm dinner at the moment. Catch you next time.